We're going to be working with how to divide expressions that have exponents in them, and we're also going to work with negative exponents. So let's start with a couple rules which should make sense to you because we've been multiplying them, and when we multiply, for example, x to the third times x to the seventh, we learned that is x to the 10th. We added the exponents. Well, now my first rule is that if I am dividing, and once again notice that I have like bases here, they're both the same base, then I just subtract the exponents. It's exactly what you think it is. It's x to the m minus n. So, for example, if I had x to the 14th over x to the 9th, I subtract the exponents, and that would be x to the 5th. Let's look at another example. Let's say that we have, we'll do a pretty basic one, k to the 7th, m to the 10th, p, over k to the 2nd, m to the 3rd, p. So this one's not real bad. All we need to do is subtract exponents. So first, let's deal with the k's. Well, 7 minus 2 is 5, so that will be k to the 5th. M is 10 minus 3, so that's m to the 7th. But the p's are both a 1. So 1 minus 1 is 0. Well, this brings us to another rule. Let's come over to the side real quick and note that anything to the 0 power is just 1. Anything to the 0 power is 1. Y to the 0 power is 1. 18 to the 0 power is 1. It doesn't matter what it is. Anything to the 0 power is 1. So what this really means with these p's is 1 minus 1 is 0, so this is just like a 1. So really what we can do is just mark them out. They just go away because they're like a 1. All right? So this is my final answer right here. Let's do another one. Let's say that we have 2y squared over 3y all to the third. Well, this third power needs to be distributed to everything in here. Don't forget the coefficients out in front. So this is 2 to the third, y to the 6th, and now we're using that power that we learned the last couple days, 3 to the third, y to the third. Well, we can clean that up a little bit. 2 to the third is 8. 3 to the third is 27. And then I need to subtract these. 6 minus 3 is 3, so I have a y to the third. Now where should I put it? On top. Because I had a y to the 6th, think of what that would look like. It would look like this. All right? And y to the third would look like this. So if these go away, I'm left with the y to the third on top. All right, so that's why it's on top. Now let's talk about negative exponents. Negative exponents are important, just like all the other things we do with the exponents. Two simple little rules. Here we go. A to the negative n power. What does a negative exponent mean? It means that it gets moved from where it was to either the top or the bottom. This one's on the top, so it goes to the bottom and it becomes positive. So this is 1 over a to the positive n. So if I have a negative exponent, I can just move it to the bottom. All right? By the same token, if I have a negative exponent in the bottom, like 1 over a to the negative n, it goes to the top and becomes positive. So this is a to the positive n, and I could write it over 1 if I wanted to. I don't have to. So they basically just trade places. And then all of our other rules still work that we've learned. It's just a negative number. So let's do a few examples with these negative exponents. You're going to be asked to simplify some expressions that have negative exponents in them. We'll start with this one. N to the negative fifth, p to the fourth, over r to the negative second. Now this one's not real bad because there's just one of each variable. So all I really need to do is move things around. This n to the negative fifth needs to come down here. This r to the negative second needs to come up here. And when I do that, the powers become positive. So the r to the second will now be on top. The p to the fourth does not go anywhere. And the n to the negative fifth is now n to the fifth in the bottom. And that's all I can do to this one. That problem is done. Let's do one more. A little bit longer problem. Has a few more steps involved. Let's say that we have this expression. 5r to the negative third, t to the fourth, all over negative 20, r to the second, t to the seventh, u to the negative fifth. Okay? Well, there's a couple different ways we could tackle this problem, but the first thing that I would do is take care of simplifying this, the 5 over negative 20. Isn't that just a simple fraction to reduce? That's going to become negative 1/4. Doesn't matter where you put the negative, I'll just put it on top. Well, we've got a negative exponent right here. So that goes to the bottom. So now my r to the third is on the bottom, but there's also an r to the second. So those two get multiplied together. So I'm going to have an r to the third times an r to the second because this thing came down here. Well, now I have this t to the fourth over t to the seventh. Well, didn't we learn we can subtract the exponents? So what's 4 minus 7? Isn't that negative 3? So I have t to the negative 3. Well, that means it needs to go to the bottom. So now I have a t to the third in the bottom. All right, I have to deal with this u. Well, it has a negative exponent, so this thing needs to come to the top. So now I have a u to the fifth on top. There's one more thing I can do. Can't I do something with these r's? I can add the exponents. So that'll become r to the fifth. So I have negative 1 u to the fifth over 4 r to the fifth t to the third. And we will stop there for today.